In this video, I'm going to discuss about rocks. Rock, it is a material of the lithosphere. Lithos means rock. The Earth's crust is composed of oxygen, silicon, aluminum, iron, magnesium, calcium, potassium, and sodium. Whereas the major elements in the crust are oxygen with 46% and silicon about 28%, aluminum 8%. Whereas when we take the Earth as a whole, we see that iron is a major component. Iron is about 35%, oxygen is about 30%, and silicon is about 15%. Classification of rocks. On the basis of mode of formation, it can be classified into igneous rocks, sedimentary rocks, metamorphic rocks. These rocks, igneous rocks, can be transformed into sedimentary rocks because due to weathering, due to disintegration of rocks, and these disintegrated rocks sediment and they consolidate and they become compact and they form sedimentary rocks. These sedimentary rocks, they undergo some changes under intense heat and pressure and they can form metamorphic rocks. Whereas the sedimentary rocks, again they can form metamorphic rocks. Even these metamorphic rocks, again they can remetamorphize and they can form another metamorphic rocks. These metamorphic rocks, again they can form sedimentary rocks. Again sedimentary rocks. These sedimentary rocks, so it's like a cyclic thing that one rock can be transformed into other rock. Igneous rocks formed due to cooling, solidification and crystallization of molten magmas and lavas. These rocks are called as parent rocks or primary rocks. These characteristics of these rocks are hard rocks, and percolation of water is difficult because these rocks are hard rocks and percolation is possible only at the joins. Rocks are granular or crystalline in nature depending upon the cooling rate of magma. Sometimes these rocks are not granular also. Crystals won't be there in this. If it is cooled faster, grain formation is less possible, and if cooling is at slower rate, crystals form. So this cooling at slower rate takes place within the earth. When it comes out of the earth, the lava, when it comes out of the earth, the cooling rate is much faster, so the grain formation is less possible in those rocks. These rocks have no strata or layer, but layer formation can be seen due to difference in the period of lava deposition. Say here on lava, here up 50 years ago lava deposited, and another after 50 years again lava deposited on that. So we can see the difference. It looks like a layer, but strata is not there in these rocks. Less affected by chemical weathering because water percolation is less, that's why less affected by chemical weathering. And weathering possible, physical mechanical weathering is possible. This physical mechanical weathering leads to formation of sedimentary rocks in the region where it gets deposited. Do not contain fossils because during rock formation either the life did not exist during the formation of crust or otherwise high temperature of lava could have destroyed the remains of plants and animals. So these rocks have no fossils and has many joints due to cooling and contraction. During cooling and contraction, there are like a crack like joints are developed. Through these joints only water can percolate down, so that it has the weathering, chemical weathering is least chemical weathering takes place at where these water gets contacted at the joints associated with volcanic activity. So these rocks are called as volcanic rocks. Classification of igneous rocks based on the amount of silica these can be. So this is not depending upon the pH of the rocks, but this is dependent upon the amount of silica which is present in the rocks. It can be classified into acid rocks and basic rocks. Based on the chemistry and mineral composition, it can be classified into felsic, mafic and ultramafic rocks. Based on the mode of occurrence, it can be classified into intrusive rocks and extrusive rocks. And based on the texture of grains, it can be classified into pegmatitic, phaneritic, aphanitic, glassy and porphyritic. Acid igneous rocks. These rocks have silica content of 60 to 65 to 85%, so which has more silica. Average density is 2.75 to 2.8, and dominant minerals are quartz, feldspar, and they lack in iron and magnesium. Less erosive, hard, mainly used in building material like in granites they are used, which has a higher silica content. Basic igneous rocks, they have a lesser silica content which is about 45 to 60%, and average density varies between 2.8 to 3, and dominant minerals iron and magnesium, whereas here the dominant, they lack in iron and magnesium, whereas here the dominant minerals iron and magnesium, easily eroded, heavy and fine grained, dark in color, example basalt. Felsic igneous rocks, so these are like these the rocks features are like as acidic rocks, and the mafic igneous rocks similar features like basic rocks. Ultramafic rocks, they have a silica content of less than 45%, and average density is about 2.8 to 3.4, and minerals pyroxene, olivine are more. In this all minerals pyroxene and olivine are more, and example peridotite. Pegmatitic rock, they are very coarse grained large crystals. These rocks have a coarse grained large crystals in it. Phaneritic, they are coarse grained rocks, which means phaneritic means visible. Phaneritic means visible, but aphanetic means invisible. So they are fine grained. Phaneritic has a coarse grain, but aphanetic has fine grain, which means aphanetic means invisible. Glassy rocks has no without grains. There is no formation of grains in this. Porphyritic is mixed grained. So large grains, small grains, everything mixed in these rocks. Intrusive igneous rocks, they are formed due to cooling and solidification of magma below the surface of the earth. So intrusive means they are within the earth itself, inside the earth. And types of there are two types in it. Plutonic rocks, they are more deep inside the earth, whereas hypabasal, which is just above, just below the crust. These hypabasal rocks are just below the crust, but plutonic rocks are formed just deep in the earth. They are cooled deep inside the earth with large grains. So because it is cooled deep inside the earth, so it has a large grains, because the cooling time which it takes is much longer than the other rocks. Solidification of hypabasal has solidification of rising magma at cracks, surfaces, pores. These are called examples batholiths, laccoliths, phaccoliths, sills. So batholiths, it will have a irregular shape, and lacos means rocks, laccoliths means rocks, and phaccoliths means, so these rocks will have magma along the anticlines and synclines. See, like this anticlines and synclines are there. Here the magma will be solidified here, so cooled and solidified here. So this is called phaccoliths. And sills, it's like a wall like shaped bedding plans are there. See, here one bedding plan is there, and here one bedding plane is there. So between these sills will be deposited, solidified and cooled. And dikes will be wall like formation. Dikes like this wall like formation will be called as dikes. Extrusive igneous rocks, they are formed due to cooling and solidification of lava at the surface of the earth. Example basalt. So here we can see, so sills are formed like this between the bedding planes. So here is a bedding plane, here is a bedding plane. So in between these sills are formed. So dikes, they are like a wall like structure. They are formed like a solidified like a wall like structure. And laccolith have, lithos means a rock, a large rock is formed here. And batholiths, they have a irregular shape, so no shape, but most of the time when we see, they are like a dome shaped rock structure. And so this is the here these rocks are the extrusive rocks. Extrusive rocks, when if it is below this layer, then they will be called as plutonic rocks, but above this, if we call it as, they are extrusive rocks. So some examples of igneous rocks are andesite, basalt, diorite, gabbro, granite. Some commonly known names are granite, peridotite, so pegmatite. These are some examples for igneous rocks. Igneous rocks, the color of the igneous rocks changes with the parent materials. The minerals which is there in these rocks, granite can be in any color. So depending upon the parent minerals, so which mineral is more, so depending upon that, the color also varies. And depending upon the cementing material, so the erosion or the